Welcome to this video and the Trivial File Transfer Protocol or TFTP. TFTP is a simple lightweight protocol used to transfer files across a network. Unlike FTP, it does not require login credentials and uses UDP for fast and minimal overhead communication. TFTP is commonly used for tasks like booting devices over a network, transferring firmware, or updating configurations on routers and switches. TFTP is often used for network booting, firmware transfers, and updating device configurations. Operating on port 69, it handles basic file operations, reading and writing files in small blocks. TFTP utilizes five primary message types to efficiently manage file transfer over a network. The read request or RRQ is sent by a client when it wants to download a file from the server. In contrast, the write request or WRQ is used when a client needs to upload a file to the server. Once the request is accepted, the data message carries the file in small sequential blocks, typically 512 bytes each. To ensure reliability over UDP, the client or server sends an acknowledgement for each block received. This confirms successful delivery and keeps the transfer on track. If a problem occurs, such as a file not found, an access violation, or a disk full, an error message is sent including an error code and a short description. Together, these messages allow TFTP to perform simple, reliable file transfers quickly, making it ideal for tasks like network booting, firmware updates, and device configuration in trusted networks. TFTP is connectionless, but a logical connection is formed using the request and acknowledgement process. This diagram illustrates the connection establishment process of the TFTP for reading a file. The client initiates the process by sending a read request to the server, specifying the file name and the transfer mode, typically ASCII. The server then responds by sending the first block of data back to the client. Each block is acknowledged to ensure reliable delivery. If there is an issue in transmission, the server can alternatively send an error packet indicating the problem. This simple request response mechanism forms the basis of TFTP's lightweight UDP-based file transfer process, ensuring that data is transferred efficiently with minimal overhead. When a client wants to write a file to the server, it sends a write request, also known as WRQ. The server responds with an acknowledgement of block 0, signaling a readiness to receive data. The client then sends the file in sequential data blocks with the server acknowledging each block. The transfer concludes when the final data block is acknowledged. If there is an issue in transmission, the server can alternatively send an error packet indicating to the problem. This simple yet reliable process of requests, data blocks, and acknowledgement ensures efficient file transfer without the overhead of complex protocols, making TFTP a perfect solution for lightweight file operations. Let us understand how UDP port numbers are used by TFTP. In the beginning, the TFTP server performs a passive open on UDP port 69 waiting for client requests. When a client wants to communicate, it performs an active open using a random port, for example, port 50032 and sends a request to the server's port 69. After receiving the request, the server responds from a new random port such as 62000. From this point onward, all data transfer takes place between the client's port 50032 and the server port 62000. Remember, port 69 is used only for the initial request, while the new ports handle the actual file transfer. Let us look at how TFTP handles a simple file transfer and ensure reliability even though it uses UDP. The client wants to retrieve a 2000 byte file named file1. To begin, the client sends a read request or RRQ to the server. The server responds with the first data block carrying the first vital bytes. The client receives it successfully and sends an acknowledgement. These two messages together establish the TFTP connection. Next, the second data block containing another vital bytes is lost during transmission. After a timeout, the server retransmits the lost block and the client acknowledges it. The third data block arrives intact, but this is the time the acknowledgement is lost. After another timeout, the client retransmits the acknowledgement, keeping the transfer synchronized. Finally, the fourth data block, which contains the remaining 464 bytes, arrives damaged. The client discards it and waits. After a timeout, the server retransmits the block successfully. Since this block is smaller than vital bytes, it marks the end of the transfer and terminates the connection. This process shows how TFTP maintains reliable file transfer using simple transmission and acknowledgement mechanisms over UDP. TFTP records only a small amount of memory and uses the basic services of UDP and IP. Because of its simplicity, it can easily be stored and configured in ROM or PROM. When a network station is powered on, TFTP automatically connects to a server to download its configuration files. The process begins with the station using a DHCP client to obtain the name of the configuration file from the DHCP server. Once the file name is received, the station passes it to the TFTP client, which then communicates with the TFTP server to download the actual configuration file. This lightweight and automated setup makes TFTP ideal for putting diskless workstations, routers, and network devices that need to load their configuration during startup.